Hi guys, this is the Innovative Minds Tutor. In this video, we are going to learn about rules for differentiation. The rules for differentiation allow you to differentiate function without going through the process of differentiating from first principle. So in this video, we are going to learn about the rules of differentiation. So we are going to learn about rules of differentiation. Let's consider the first rule. Consider this rule. We'll call it rule 1. Okay. Rule 1 says that the derivative of a constant is equal to 0. Okay, the derivative of a constant is equal to 0. Right, meaning that if I have f of x is equals to k, where k is a constant real number, where k it's a what? Constant real number. Where k it's a constant real number. Okay, so that's the rule 1. Rule 1 says the derivative of a constant is equals to 0. It doesn't matter how you name them, but what is important is to know the types of rules that are applicable for differentiating, yes, from using the rules of differentiation. Okay, so let's consider we are having f of x is equals to 20. So what will be the derivative? Mind your notation. The derivative of f of x will be equals to 0. The derivative of a constant is equals to 0. Don't forget that. Derivative of a constant is equals to 0. If I have f of x is equals to 20, that will be 0. Even in cases like this, let's say we are having f of x is equals to maybe x squared plus 20. Right? You know that when you will differentiate this, the derivative of f of x, so this will be, using a power rule, it will be 1 times 2, that will be 2. Then with x here, 2 minus 1, that will be 1. Then what is the derivative of 20? Since it's a constant, it's going to be 0. So we are going to say 2x plus 0, that will be 2x. Right? So hope you have learned something from rule 1. Let's name this rule 2. Consider the second rule. The second rule, we'll call it a power rule. We will call it a power rule. A power rule. Consider, let's say you are having f of x is equals to x to the power of n, right? So where n, it's a constant real number. So, but how do we differentiate this? We will do like this. Differentiation of f of x, n, there will be this invisible coefficient of 1. 1 times n will be n times x to the power of n subtracted by the power there. We subtract the power by 1. So this is the rule that we are going to use whenever we differentiate a function, right? So the power rule, it's very important, especially when you're differentiating. Let's consider, let's say you're given f of x is equals to x to the power of 10. So you're supposed to differentiate this. All right, to differentiate this, you are going to say the derivative of f of x is equals to, remember this invisible 1 of a coefficient. This will be 1 times 10 multiplied by x to the power of 10 subtracted by, subtract the power by 1. So what will happen here? 1 times 10 will be 10, as well as 10 minus 1 will be 9. So The derivative will be f of x. Derivative of f of x is equals to 10 to the power of x to the power of 9, x to the power of 9, right? Let's say maybe we were given this in this manner. Let's say we are given f of x, it's a function, 2x squared plus 3x plus 5. So using a power rule, we will say the derivative of f of x. Remember that this coefficient will multiply the power, so it will be 2 times 2 times x. The power is subtracted by 1 plus, subtracted by 1 plus 3. Remember that there's invisible power of 1 here. 3 times 1 times x. Then the power of 1 will be subtracted by 1 there. So what is the derivative of 5? Derivative of 5, that will be 0. So when we are here, guys, remember the derivative of f of x. So what is 2 times 2? That will be 4. 2 minus 1, that will be 1. So we can leave it as 4x, right? 3 times 1, that will be 3. X to the power. Let's see, what is 1 minus 1? Minus 1 minus 1 is 0 there. So there's no need for us to put 0 there. Here, there's no need. So what are we left with here? We are left with 4x at any base that is powered by 0. That's the definition of an exponent. Any base that is powered by 0, that's 1. So 3 times 1, that will be 3. So that will be the solution behind this. So we are going to the third rule. Right. Now we are going to the third rule. Rule 3. Okay. All right. Rule 3 actually says the derivative of a function multiplied by a what? By a constant. That's rule 3. Remember, we're working with rules of differentiation. The derivative of a function multiplied by a constant. What happened? Let's see. Let's consider if f of x is equals to, let's say we are given k multiplied by g of x. So what will be the derivative? The derivative will be f of x there is equals to k, where k it's a constant. It's a constant real number, don't forget that. Then what would be derived is g of x, the function of g of x, right? Okay, so that's the third rule. So let's apply that rule. We'll apply the third rule. Let's consider you have f of x, right? Maybe 3x to the power of 4. So what is happening here? Remember I told you the derivative of function multiplied by a constant. What is going to happen here? We are going to say 3 multiplied by 4 multiplied by x as well as 4 minus 1. So what is 3 times 4? That is 12. So what is 4 minus 1? That is 3. So that's the derivative. Yes, that's how you can apply this third rule, guys. Hope you are learning. I hope you are learning, guys. This is very important. These are important rules. Let's consider rule 4. Rule 4. Rule 4, it's a sum rule, or what we call an addition rule. Sum or addition rule. Okay, so let's say we are having a function of f of x is equals to a function of g of x plus a function of h of x. So what will be the derivative? The derivative of f of x is equals to the derivative of g of x plus the derivative of h of x. Okay, without wasting time, let's put this into practice. Let's say I'm having f of x is equals to x cubed plus 2x cube So we know how to differentiate this. Remember, there's a coefficient to multiply the power. 1 times 3 multiplied by x, and 3 minus 1 plus 2. Yes, remember, this is a derivative of a function multiplied by a constant. So it's going to be 2 times 3 multiplied by x, as well as 3 minus 1. So what are we waiting for? 1 times 3, it's 3. Then what is 3 minus 1? That's 2. Then what is 2 times 3? 2 times 3, that is 6. 3 minus 1, that is 2. So definitely this will be our solution. Hope you find this video useful, and don't forget to subscribe. So let's go to the last rule, guys. We are going to work with the last rule, which is rule 5. Right? Rule 5. We are working with rule 5, guys. It's a difference rule. The difference rule. We know when you talk about difference rule, we talk about subtraction. There's a subtraction there. So let's consider f of x. If f of x is equals to g of x is minus, h of x. So what will be the derivative? The derivative of f of x and the derivative of g of x subtracted by the derivative of h of x. So consider this. We are given a function of f of x is equals to 2x. X what? X cubed minus 2x squared. So we are required to determine the derivative. So to determine the derivative of f of x, what are we going to do? F of x will be, then remember that the coefficient, which is 1, multiplied by the power, which is 3, 1 times 3, multiplied by x, as well as 3, minus 1, minus 2 times 2. Remember that the coefficient multiplies the power, multiplied by x, as well as 2, subtracted by 1. All right. So what is happening here? 1 times 3, it's 3. 3 minus 1, it's 2. So the derivative of x cubed, it's going to be 3x squared. So let's consider this one. 2 times 2, that will be 4. What is 2 minus 1? That will be 1. So we are actually left with derivative of f of x, which is equals to 3x squared minus 4x. All right, guys. Hope you find this video useful. Let's grow this community by subscribing and like the video. Let's like the video so that we get more audience, so that we grow the community. Right? We are around on 330 subscribers. We are working. Thank you, guys. Keep subscribing and share the video. We love you.